afternoon, everyone. I'm Queen Luong. I'm a principal at EHCD. Yes, you are in the right place. Your programs say that we are seeking carbon clarity in this session, but here's the reality. In conversation with this really incredible group of panelists, what has emerged is that we're really here to wrestle with the tensions, the challenges, and let's admit it, sometimes the outright contradictions in how we design and deliver low carbon envelopes. So a little bit of table setting. Typically, we design buildings for 50 plus years. Climate data gets updated every 5 years. We often optimize for performance metrics that maybe are not in alignment with what the human experience of these spaces are. We often present these beautiful visions to clients, and oftentimes they're not always in alignment with what we understand as best practices for low carbon design. Whether it's new buildings or existing structures, there's definitely a gap between design intent and the actual as-built reality. And it's this gap that renders all of our careful calculations a little bit ineffective. So let's start with a very fundamental question. What does a low carbon envelope even mean? Yes, it's about the embodied carbons in material. Yes, it's about the operational energy over decades. Yes, it's about durability, adaptability. And yes, all the above, in all the above, we're really still trying to navigate and figure out what the trade-offs are. So for the next 45 minutes, we're going to be really looking into the tensions, these tensions, whether they be in the early design decision phase or through construction and even to that long-term performance. Where we're going to end up is what I think really matters, which is how do we collectively build a knowledge base that helps really move the field towards this idea of a low carbon facade. Fortunately for us, we have this really deep bench of expertise on stage. They represent academic research, iconic built work, development perspectives, as well as construction delivery. So let's just go ahead and get right into it with some introductions.
First, Queen, thanks for the opportunity to be on this panel. I really enjoy these conferences. I've been to a few now. I'm with the Center for the Built Environment at UC Berkeley. I'm actually a product of the UC Berkeley architecture program. I spent about 10 years at Gensler before joining CBE. One of the things that's unique about CBE is we have a consortium of between 40 and 50 companies, and these are industry professionals, they're builders, they are manufacturers, they are owners, they're tech companies, and they collaborate with us, they support our work and guide it forward, and they also collaborate with us on ongoing projects of many types. And those span from indoor environment, comfort, air quality, to energy, HVAC, envelopes, and more embodied carbon and life cycle assessment. And we build a lot of tools too. So the thing that's relevant to this audience, to all of you, is a few years ago we created what we call the facade map. Our goal was to identify and document appropriate and interesting climate responsive buildings from around the world. We started in North America and Europe. We created this website where we feature these. In many cases, for example, this project, Bloomberg, by Foster Partners, we actually had one of our colleagues who was on the faculty, and he was able to really fill in a lot of the details about this project. So we typically have this taxonomy of details that we show. We have image pages as well. So we've had a few projects like this where design team members have provided the information. More generally, it's students that have done this just using published available resources, and I invite you to look at it. And I have some other things that we could talk about later.
Thanks, David. And thank you to the Architects newspaper and Queen for inviting me to today's conference. So my name is Ben Dobbin. I'm the senior partner here in San Francisco for Foster Partners. And I'm proud to be part of a team that's been delivering for over 50 years of innovation and sustainability at all scales, from master plans through to buildings and also products. And some of these are actually in the local area We can go and visit them anytime. And for today, I was kind of inspired by one of the projects, which is a little bit far away from where we are now, but if you think about it, it really comprises the challenge. What do we have, and what do we want to do with it? So what do we have? We only have one planet. And when it comes to building something on the moon, you're challenged by what do we need? Well, you can only take a limited amount of material when you travel to the moon. So what is the essential minimum requirement that you need to be able to construct a habitat or create architecture? And I think that's really something which should drive our thinking. And from space to the spaceship, which is just down the road in Cupertino, the project which brought me here to California, which is really determined by a passive fixed shading system, which is trying to do more with less. An envelope which is breathing, which creates a natural ventilated, 70% of the building is naturally ventilated for 70% of the year, 20,000 solar panels on the roof of it. It's a net zero energy building and home to 12,000 employees, and which harnesses the technology of glass and structural glass to be able to do more with less. And I think that's another principle which underpins our practice and a way of thinking which we have to take to challenge ourselves to create these lower carbon envelopes. Thank you.
Good afternoon. My name is Brett Stuckey. I'm the Sustainability Manager for Turner here in Northern California. It's really good to see so many friends in this room. A lot of people that I know, some people that I might even talk about a little bit later. But at Turner, we've been named the #1 green contractor for the last 18 years, which is a really cool thing to say. But in reality, that just means that we have a lot of people who took the LEED AP test, and we have a lot of green revenue. I think in general, we have a lot of revenue, so it seems by default that should be the case. But the reality is in the words of Uncle Ben from Spider-Man, with great power comes great responsibility. We try to put that into practice in our daily jobs. We have a comprehensive ESG policy, building today to transform tomorrow, that includes a lot of environmental training and understanding and practice in what we do. We do a lot of embodied carbon tracking. We're trying to reduce our carbon, water, and waste on our job sites, and that's what takes up my 40 hours a week before I get to go home and hang out with my lovely kids. So happy to talk today with everybody on stage. It's fun to listen to some of their really cool stories, and I'm excited to share some of mine a little bit later.
Good afternoon, Tolga Tutar. I'm with Skanska. I'm Senior Sustainable Director based in Portland, Oregon, but I work nationally and talk about decarbonization every day, all day. We are a general contractor, but also a developer. We have been around 135 years. Originally a Swedish company with global headquarters based in Stockholm, Sweden, but we have operations in EU and in US. I'm really excited to have this conversation because decarbonization is becoming a popular topic, not just because it's coming from our clients as demands, new project requirements, not just because policies, regulations are becoming more and more stringent, but it has been a fundamental part of our operational strategy and business model for almost 2 decades. We actually started tracking our carbon emissions back in 2008, or tried to track, and quickly realized we don't have the tools in place, there's no data. It took probably 7 years to get everything together, and in 2015 we made a commitment to become net zero carbon construction company by 2045. And we made interim carbon reduction goals by 2030. We already reduced our operational carbon emissions by 61%, already reduced our value chain emissions, which is directly related to embodied carbon emissions with materials, by 37%. So I always have a pleasure to have this conversation with our teams and external partners, but I'm always the annoying guy on the table, just bringing another complexity to our projects. And depending on the audience, I get like squinted eyes, what are you talking about, man? Or skeptical head tilts. Now I have to deal with GWPs, EPDs. We got better internally. Even our superintendents can tell you what embodied carbon is today. But depending on the audience, you get different results. But I don't get that vibe here. I know I'm in the right place with the right people. So I'm looking forward to this conversation.
So this panel represents a broad spectrum of the built environment practice. Let's just start with that fundamental question. What is a low carbon envelope? David, do you want to start first?
Sure. I think sort of in the context of the case studies that we were looking at, I would confess that we were a little biased to things that are really interesting and innovative, but we were really mainly looking at operational performance. And we were especially looking for things that had third-party certification because it's hard to find operational data on buildings. It's elusive. So we were looking at things with very high LEED ratings, for example. I think so the project is kind of static right now, but I think going forward, I think embodied carbon would be probably a higher consideration in the selection of projects. So both operations and, of course, embodied.
Yes, I would agree that the focus has shifted from not merely talking about performance, and that has to be, it has to deliver on performance for us. It has to have a holistic approach there, but really measuring down to what are the components within that and what is their carbon load and how does that contribute, and really then looking at the weight of materials specifically and the types of materials which we're looking at. And it's difficult because there's many avenues you could go on depending on the code, the type of building you're working on, the place where you're working on, the height of the building. So there's no one answer to this question.
Toga, I think that one of the most provocative things you said in our previous conversation is that envelopes are that first line when we think about what low carbon design is in general, because it is the element that separates the environment or allows the environment to come through. Can you speak more to that, especially relative to, whether it's a new building, an existing building?
Sure. These low carbon material system building conversations is always fun because the first question comes to mind, lower than what, right? Operational carbon emissions, relatively speaking, it's easier because we have energy codes in place, we have data, and it's just related to energy use. But embodied carbon, as David mentioned, is a more complicated topic. We are still in the learning phase, I guess. But yeah, overall, low carbon envelopes are building skins that are optimized to minimize both operational carbon and embedded carbon in building level, not just in facade level, right? Facades are really the first line of defense. It has been exciting to see facades evolve from an aesthetic curb appeal and basic weather protection to a critical component of energy efficiency for the whole building, and now becoming probably the most critical asset in a building to manage climate risk, financial risk, and quality. There are lots of different issues that we identified through our project work to define what is low carbon and how it interacts with other building systems. And we have done lots of research over the time. Maybe I can share a couple of things. If you can go to the next slide, maybe, Quinn. For us, understanding how buildings interact with each other was really key. Especially this became apparent for a particular project we were working on back in 2018. For a high-tech client, for a large campus with all the buildings were pursuing LFI, zero carbon certification, LEED Platinum, Fitwel, you name it, all the certifications. And it has been hard to identify what is low carbon. And on the design side, with our design partners, with the whole building lifecycle assessment tools, we had pretty good data, but translating that to construction, tracking all aspects of different embodied carbon emissions related to transportation, construction, how different facade decisions impact those, how they impact the end-of-life emissions, waste, etc., was complicated. So this problem created an opportunity for us with Microsoft, Carbon Leadership Forum, Sea Change Labs, and many other industry partners down the road. We created a tool for us to get through that problem, also better understand what facades impact are on embodied carbon especially. EC3 tool has been around for 6-7 years. We started working with EC3 tool on that particular project. It has proven itself to be very useful. Then we made it mandatory for our development projects to use it. And it was super useful. Then in 2019, it was publicly available for free. It's free to use for everyone. A new nonprofit called Building Transparency was formed to keep it independent and make sure the tool continues to grow. And in 2021, we made it mandatory for all construction projects. Even if there's no sustainability goals for the project, we wanted to have a preliminary embodied carbon assessment for facade all building systems as a conversation starters to better understand different projects. So in 7 years, we have hundreds of models now, so we better understand what are the impacts of, so to speak, low carbon facades. If you can go to next slide, like this is just some data based on hundreds of different EC3 models. For ground up new construction, obviously the main focus is structural system, because concrete, steel are highly carbon intensive materials. They are used in high quantities. But then facade, envelope systems, and MEP system come in place. And if you just isolate facades, like they are considered as a passive component of the building, but they have a very dynamic relationship with MEP systems, heating, cooling, ventilation. So when you optimize the facade system, it has lots of different impacts, different embedded carbon impacts. Maybe you are evaluating different design options between single skin facade or double skin facade. So if you just look at this problem in a facade level, double skin facade has more embedded carbon because more materials, more embedded carbon. But what's the impact in building level, right? By optimizing MEP system with facade, you can downsize the mechanical system maybe, which means less materials for MEP systems, less refrigerants in energy efficient system. Refrigerants leaks, they have a high embedded carbon footprint. Maybe you can optimize facade system to reduce transportation or construction emissions for contractors with more prefabricated modular systems that can be installed in a very short amount of time. And what about end-of-life emissions, which is also part of embedded carbon emissions? Can you design building assemblies, facade assemblies that are easy to deconstruct at the end of their lifespan, or that can be replaced quickly for maintenance or replacement purposes? So they all are part of what we call low embedded carbon facades. So we have to think about this problem beyond operational carbon emissions or embedded carbon emissions just in facade level, but more in building level. And maybe one other thing that I would like to underline, we did some other research. If you can go to next slides. Facades are really the first line of defense for embedded carbon for new construction, but they will play a bigger role in transitioning the existing building stock. Because when you think about this from operational carbon emissions perspective, it's almost no-brainer to demolish an existing building that's 50-year-old, that are outdated, and that has high operational carbon emissions because it's not energy efficient. So just demolish the building, build new, so it will have lower operational carbon emissions. But what about the embedded carbon question? Because we always have this conversation as contractors with designers, and we want to do a study. So we did a comparative study. What we did is, let's say we have a vintage building that's 30% less efficient than the current building code. What if we demolish this building and building new? Then it will have high embedded carbon emissions, but lower operational carbon emissions. And how it compares to existing buildings, higher operational carbon emissions. Like, where's the carbon equivalency, which makes more sense? And we did this comparison for multiple building typologies in 2 different climate zones, Chicago cold climate and Portland, Oregon, a bit more milder climate. And the numbers that we figured out was pretty eye-opening. If you can go to next slide. Like, from the overall carbon perspective, new construction almost doesn't make any sense because it takes decades to achieve carbon equivalency because of the very high embedded carbon. On the first day, the building becomes operational. So high performance, low carbon facades are important to new construction, but they will play a very critical role for transitioning the existing building stock. Adaptive reuse, deep energy retrofits, major renovations, where we keep the structural system intact, but change the entire envelope and mechanical systems in an optimized manner, will be a very important strategy to tackle like embedded carbon emissions and operational carbon emissions at the same time.
Any additional thoughts on defining low carbon envelopes?
I'll just add that at this conference, we've seen some really interesting, full facelift renovations of existing buildings. We've got one on our case study in London. Arup did a renovation of a building where they actually removed all of the window structures, but put new glazing in. I think it was 1 or 2 years ago, Gensler presented this great project where they added these sort of shading canopies and added floors onto a building. So there's great creative stuff that can be done with keeping structures.
Why don't we go to the experience versus performance gap? How do we translate high performance metrics into palpable, visceral human experience that bridges kind of the gap between what we're designed for versus what is the lived experience?
Well, I think we always want to take the performative elements of a building, and that's our tools for expression or the architecture. And one of the projects which we have here, if you just flick it on, this is a Maggie's Center, which is a place where people who are suffering from cancer can go and speak to other people who are going through similar problems. It's adjacent to a very corporate, well, like I said, sterile hospital, as they all are, and it's set in a garden. And the whole construction is made of timber. And if you were to go on one, the whole environment is defined by these engineered trusses. And this isn't mass timber. This is a timber structure which is lightweight. It actually takes lessons from the aerospace, well, actually just airplane design, early airplanes which were designed with timber, and creates this modified, improved truss. So there's a lot of analysis which went into the design of this truss in terms of removing material. And a lot of the carbon content in a facade is in the support structures, in what holds that facade up, whether it be steel or aluminium, the supporting structures. And this one is basically using that as a spirit of the design, and it's actually enhancement, obviously, and it becomes the architecture, and the softness of the wood is, biophilic and warming and soothing. So that's an example where we borrow from another technology and another discipline, and it informs our architecture. And whilst this is a structure of a building, you can transpose this onto the structure of a facade and start to think laterally like that. And then, similarly, this is a whole project which we've done now for a whole winery project in Spain, where the entire built structure from wood through to the facade, from the main structure through to the facade is structurally engineered in timber. And so we're looking at this holistically, how it carries through. And with these smaller scale projects, there's no reason why we have to rely entirely on aluminium facades for code. So I think there's a lot of building typologies where we can really go all out on renewable materials before we even start talking about recycled materials, the other components. The next, and it even becomes the skin and the shading system. So this is a holistically timber construction and renewable resource. And this building is actually entirely renewable, and the photovoltaic panels which are on this building actually support the entire winery as well. So it's really thinking about, again, how those materials enrich the architecture.
So David, one of the interesting things that you noted in our conversation was this tension between the allure of connection to nature with very translucent, transparent facades, and then the reality of the implication of what that means from a carbon perspective. And there's a certain tipping point where the view shed and what do we actually need from a facade to get us to have that connection, that very visceral experience, versus the reality of the embodiment carbon within any system. And what do you see are some of the tensions between that, and how do we evaluate that?
Right. So one of the research trends that we were talking about is CBE is now looking at view quality. We've done some studies, and there's other research too showing that view can have positive impacts on students, on patients in hospitals, especially when you have view to sort of green spaces. And we've kind of done some work in our lab too, looking at the benefits of view. And then with a group of collaborators from around the world, developing really some metrics for how do we measure and designate what is a good view in terms of quality. And there are three components. It's the content of what you're seeing. Are you seeing nature? Are you seeing distant views? Are you seeing varied levels of things? Are you seeing movement? There's the access. How far away are the windows from where you're sitting? How wide are the windows? And then clarity. If there's glare and the shades are dropped all day, you're not getting the benefit of view. And so then one of the other studies, and this was done using VR, kind of expanding the range of glazing for the subjects, and the view, as the angle of view was increased for these subjects, of course they liked the view better and better and better, but it reached kind of a maximum of around 65% of the window wall area. And after that, it didn't seem to benefit the subjects a whole lot more. So there maybe, it's an ongoing debate about, how much glazing we need. We know that many clients really want to maximize that. There's the transparency in the view. But at what point is it optimal, I guess, is a big question. And so coming back to some of the case studies that we looked at, and, just building on what Tolga said about the embodied carbon, for example, of a double facade, if we have a fully glazed facade and we're, mitigating the impacts of that with extra layers of glass and extra shading, we're increasing the footprint of the embodied carbon. So maybe, there's a balancing, there's a balance point for the amount of glazing.
Tolga, do you want to talk a little bit about early decision client education, or do you want to save that for later?
Maybe briefly. Embodied carbon is especially embodied carbon emission is a very complex topic. I guess we have to embrace that. But the good thing about it, the earlier we have these conversations, the easier it gets. And if we have a common language, it gets even more easier. Brett and I are on the dark side, on the contractor side. Typically, people call us late in the game. Hey, there's also this embodied carbon reduction goal. But when we come to the table very late in the game, you lose 80% of the opportunities out there. It's really the most essential point to have these conversations as early as possible with contractors, with your facade fabricators, because we can bring in lots of ideas, not just about quality, constructability, but from carbon perspective as well.
Maybe that's a good segue into thinking through what engagement from a contractor perspective really means when we talk about strategies for effective low carbon design.
Yeah, this is great. I'm going to stand because I'm so amped on this topic. We got a bunch of smart people. We got people from academia. We got freaking foster partners up here. And my job is to put their research and their designs into place. And we want to make sure as the general contractor, our number one goal is to honor all of that work that was done and make sure that it gets put into practice, into the field. And so, next slide. One of the things that we've done recently at Turner is incorporate this very key line item into the scope of work of our facade contractors to say, you will, during pre-construction, host a monthly sustainability meeting where we talk about all things sustainability as it relates to the facade. And based off of the dramatic results of those handful of conversations that we have, I'm excited to say that this is going to become a standard across the West Coast at Turner, just from the work that we've seen here in Northern California. So I want to kind of highlight what this meeting is and how it presents itself, who's engaged. If we can go to the next slide. So these monthly sustainability check-ins are with our GC operations team. So we typically have a superintendent, an engineer, or a project manager for the facade in this meeting. It includes me as the sustainability person asking the hard questions about embodied carbon, A4 emissions, deconstruction, things like that. We, of course, have the facade contractor. They're the ones responsible for responding to those questions. And they spend a little bit of time, I say a little bit of time, realistically it's probably a lot of time, doing some research on the back end to prepare for that next month's meeting. And then we want to include the designer and the client. Ultimately, a lot of the contracts that we do there's a pre-construction component or it's a design build project. And whenever we have a project that's set up that way, typically the facade is a design build subcontract. So it's important for the AOR, the architect of record, and the client to make sure that their vision is being carried out. So we want to make sure they're a part of this conversation as well. The agenda for us has been, number one, how are we going to minimize embodied carbon and hopefully maximize recycled content? Where are you going to source your materials from, and what are those percentages that we're looking for? If the project happens to require an EPD because of some random certification, or perhaps the client wants to know what our carbon reduction is, what is the timeline that they would give us to produce an EPD? We want to talk about transportation strategy. An example from a meeting that I had one time was, hey, how are you guys getting this from the plant, which I think happened to be in Mexico, to our job site? And they said, well, we're going to truck it. And we were like, well, can you do renewable diesel in your trucks? And they said, let me ask. And then they came back a month later and they said, yeah, our logistics company can offer renewable diesel. If you don't ask, you're never going to get it. So these meetings give us an opportunity to ask these very, what would seem to be simple questions, but in the whatever 20, 30, 40 years that we've all been doing this, maybe those people have never been asked. We want to talk about design for deconstruction. If you're in the sustainability world or the deconstruction world, we are continuously finding challenges with facades and glazing. Either the caulking has PCBs or asbestos or there's some reason why we just have to throw the whole facade away. So what we're going to do is learn from those past mistakes and make sure that we're designing so that this facade element can be carefully deconstructed. It may not end up being used on another building, but at least we can take the component parts and recycle them so that we keep them out of the landfill. And then we want to talk about performance testing. Are we able to do something that uses less water in our testing? As a sustainability advocate who happens to live in California, a very dry state, just blowing water at a window for 5 minutes and then moving on to the next panel and the next panel gets my goat a little bit. So we want to look at what are the opportunities to test this to make sure that it is functioning properly when we put it in place. Next slide, please. Some lessons learned that I would like to share with you all. Don't assume that sustainability is making its way into design conversations. I do not intend to put down the design community with this statement, but there are so many things that those individuals have to think about, especially when it comes to facades. And operational carbon is critical. Embodied carbon is critical, but there's a lot of different decisions that have to be made, so let's dive in onto those in these meetings. I would recommend bringing somebody to take notes. There's a lot of good information that's shared, and we want to make sure that we capture that and share it with the team so that those trade contractors who are going to do their research over the next 30 to 45 days know what they're supposed to be tracking. And then don't be afraid to ask hard questions. We are all grown-ups, we're adults, and we can do hard things. I've seen a lot of success out of these meetings after some hard questions were asked. And then just maintain a list of incomplete information. If somebody says something on this call, make sure that you note it down and share it with them.
I can sign everything that Brett said, but maybe a couple of quick things to add. I mentioned about speaking a common language. It's really important to treat carbon as a new currency, and that's what we try to do in our projects. In pre-construction phase, creating a baseline for your project. Simply, you cannot reduce what you don't measure, right? Like create a baseline, create a carbon budget for your project, and make sure that the information is translated to product specifications and is also a critical part of the bidding criteria. Set bill of materials for embodied carbon tracking and use the bid exhibits as a lever with trades, right? Like provide a message to manufacturers or your supply chain what's important for your project. If you go to the next slide, in construction phase, creating low carbon bid documents are important because like perfectly designed whole building LCA model and those numbers do not have the feedback loop. It's important to track the as-built quantities, as-built EPDs, and provide it back to the designer so you can get the verified embodied carbon information. And for example, we use EC3 in bid leveling to compare cost and carbon at the same time. And most of the time, the lowest carbon is not the highest cost, but you have to analyze that and you have to get that information, EPD-based data from your supply chain. And if you go to the next step, embodied carbon is complicated, but there are like key embodied carbon reduction strategies that we evaluate with our design partners all the time. Early engagement is really the most important part. Certain contract types like traditional design build typically do not work well, but IPD, design build, design assist can help you to bring contractors, fabricators to the table early in the phase, and we can discuss all kinds of potential opportunities, and we can find the ones that are cost-effective and impactful for the projects.
We are reaching time, but I do have one prompt left, and the last prompt is actually for not only our panel, but for everyone in the audience. How do we collectively share and build a base knowledge that helps really move the idea of a low carbon facade in the field and have it be understood as a currency, as a shared value? So happy to take questions. I'll swing it over to the panelists for that. So first question, what are the biggest barriers as an industry to high performance, low carbon facades on all projects?
I think one of the difficulties is location of where things are made and where things are getting built. And you can see that really in our area here. People want to build very large buildings here, and some of the capabilities just don't exist within even 500 miles. For some building elements, yes. For some very high performance materials, no. And so a greater distribution of some of those capabilities in the industry would help. And then as architects, we also have to adapt to what you can get in the locality as well. So some thoughts.
Any thoughts on from the contractor side?
I feel like this is a cop-out, but I mean, cost is real. And so working, as Tolga said, working early with the design teams, with the client to understand the goals, and then kind of go through a target value design process to ideally get to those goals, I think is something that we can do on a regular basis.
Maybe briefly, the biggest barrier to me is the artificial perception of sustainable products cost more. If you are talking about novel products coming into the market, yes, there's an R&D cost and it's real, but most of the most impactful like carbon reduction strategies are the simple stuff. Dematerialization, just finding the robust, pure design that will help you to reduce material quantities, because simply the buildings with the lowest embodied carbon footprint are the ones that we already have, and the materials with the lowest carbon footprint are the ones that we don't need in the first place. So finding those opportunities and complementing those with the novel, low carbon, carbon negative products is the best strategy.
I believe we are up on time, but I wanted to, first of all, thank our panelists and then open up and continue the conversation. This is a complicated topic. However, we are beginning in conferences like this and in continued education to really build that foundation of what it means to have a low carbon design approach to facades and envelopes. Thank you.